Hi class, this is a mineral identification lab. I'm going to do the first one with you, and then you're going to use my information to figure out unknowns. So the first thing you need is the mineral key that I gave you as a Word document. It looks something like this on the right side here. And it has all the information that you need about all kinds of minerals. So the mineral name, the crystal shape, the color, the density, the hardness, the streak, and does it fizz in acid. And you're going to use this key, there's several tables here, to figure out unknowns. So you're just going to compare the information that I give you to this table and figure out which one it is. So for example, on the left side, I'm going to pick a sample called sample A. It's here on the block right now. And the first thing we're going to look at is appearance. There's going to be some other things too: density, hardness, streak, and acid reaction. So the first thing I want to do is look at the appearance. And I would say the appearance is kind of, I know it's hard to see, but there's 6 sides to it if you put another piece of this together. So it is a hexagon. And you can record that, or I'll record it for you, in some blanks up here. So I'm going to call this hexagonal. Okay, and I'll just write it so we remember what shape it is. And I would say that its appearance is also, if you compare it down, it's not metallic, it's glassy. I wouldn't say it's dull, and I wouldn't say it's pearly. It's kind of grayish white and glassy. Okay, maybe a little gray. Okay, next thing I'm going to do is the density, which is a lab procedure where you have to get the mass of it, which is 36.4 grams. I'll put that over here. 0.4 grams on the balance. And the way you figure out its volume is you drop it in some water and see the change in the mLs. This one says 40 right now. So if you drop it in here, it changes and adds about 14 mLs. If you count those lines as 2, 4, 6, 8, 10, 12, 14 is the change in the volume here. So this is how I'll figure it out. You don't have to do this, so don't panic about that. That's about 2.6 grams per ml is its density. So we're going to start comparing these values to the known ones. So far, if you go back to the key, we have something that's a hexagon. It's kind of clear and glassy and has about 2.6 grams per ml. So right now we can see maybe it's not pink, something with a 2.6 mLs. Might be, let's see here, keep looking here. Keep losing my cursor, sorry. Something about 2.6 might be kaolinite, but it's not irregular, or quartz, which could be what we're looking at. But let's look at some of these other things that we can test, like hardness, streak, and does it fizz in HCl. So let's look at the hardness. Has to be pretty hard. 7's pretty hard. That would scratch pretty much everything. There is a Mohs hardness scale in your book that you can look at as well. So this one scratches glass, scratches a steel plate, a penny, which is copper, and your fingernail. So I would say that's about a 7, not the kaolinite, which is only a 2. The next thing is, does it leave behind residue when you streak it? Everything does, but this one's colorless. So colorless, you look over here, we're getting close. We might be having quartz here. And does it fizz in hydrochloric acid? That means when you add this acid to it, does it fizz? And the answer is no. So I would say all of our data tends to look like this is quartz. So you can test it over here, and I will test it and see if what we have is quartz. And you can just see here, if I submit that we are correct. So what I'm going to do is go through the next samples. Here's B, C, I'll go to the appearance here, D, E, and F, and if I can get A more in, I'll do that too. But we'll at least do a few more samples. And so you're going to use these keys to identify the unknowns to the knowns and give me a list of what you think they are. Okay, have fun.